Now next topic, that is common forces in mechanics. See, in mechanics we encounter several kind of forces, right? Forces are categorized in two categories: field forces and contact forces. Suppose we think about gravitational force, and like the gravitational force we can think about the electric force, magnetic force. Then all these forces are field forces. Means these forces acts on the object without making contact with the object or without establishing contact with the object. So are considered as a field forces. Other type of forces are contact forces. When the contact between objects is established, then and then only these forces acts. Like normal reaction, when any object is on the surface, so object exert the force on the surface equal to its weight. So as per Newton's third law of motion, surface exert the force on the object in opposite direction perpendicular to the surface. That is called normal reaction. Then if we think about the component which one is parallel to the surface for the force, then that is the friction. That is the friction. If any object is placed inside the liquid, then the force act on the object, that is the buoyant force, and that is equal to weight of the displaced liquid by that object, right? Then viscous force, when the liquid is in motion or any object is moving in the liquid or fluid, we can say in broad sense, then some resistive force opposes the motion, that is called viscous force, right? Now if we think about string or spring, so if some external force is acting on the spring or string, then the stretching force act on it, or that particular external stretching force produces the tension in the string or spring. So such type of so many forces are there in the mechanics, and in standard 11th and 12th we will discuss this different type of forces in mechanics. Clear? Now next topic, that is friction. See, when any two objects, two bodies or two surfaces are in contact, at that time the contact forces develops or generated to every pair of particle which are the constituents of that object, body or the surfaces. Okay. Now this contact forces generated obeys Newton's third law of motion. So here if we take two components of these forces, so one component which is perpendicular to the surface of the contact, that is called normal reaction, denoted by capital N, or sometimes simply it is known as normal force. And another component which is parallel to the surface, that is known as friction, right? And frictions are of three types: static friction, rolling friction and kinetic friction. Clear? Now let's first discuss static friction. Suppose, as shown in the figure, a block is lying on the horizontal surface. So here, due to gravity, the weight of the block, that is in downward direction. So here we can say block exert the force on the surface, and that is its weight mg, and that is balanced by the force on the block by the surface, and that is normal reaction, or we can say normal force. Now here we can observe this thing. In practice also we observe sometimes this thing. Suppose the body is lying on any surface and we exert some external force on it, but then also body remains steady one. Actually, when external force act on the body, then body should start motion. But here, when external force is applied, then also body is not moving. It implies that definitely there is some force. Which one is opposing this applied external force, and it is balancing it. And when it is balancing your applied force, it implies that it is in the opposite direction of your applied force, or in other words we can say that particular force is opposing the motion. So that particular force parallel to the surface between these two surfaces, that is known as static friction. Why we say that is static friction? Because this particular force opposes the motion, and under the effect of it, body remains steady, right? So we say that is the static friction, and it is denoted by Fs. Clear? Now, static friction arises when we apply some external force, and static friction, that is self-adjusting force. It implies that as we increase the external force, this also increases, right? So we can say it is a self-adjusting force, and when we apply external force, only at that time it came in action, right? Otherwise no force, right? Okay, now here under the effect of static friction, body remains steady, right? So here we can say static friction is such a frictional force which opposes the impending motion, Now impending motion means what? Impending motion means the motion which should be there, but it is not there due to friction. That is called impending motion. Suppose we consider the situation like this. Here there is no friction. Surface is very smooth. Friction is almost zero. So as soon as you apply the external force, it starts the motion, right? It implies that due to friction, that motion is not observed. We can say friction opposes that motion. So the motion which should be there, but due to friction, it is not there. So that type of motion is known as impending motion. Clear? So the motion which should be there under the effect of applied force, but it is not there due to friction, that is called impending motion, and friction always opposes the impending motion. Now here in practice we observe this thing. As we exert external force, the static friction is there. Now as you increase the external force, then static friction also increases, because in practice we observe this thing. Suppose very small force is applied on the object and object is not moving, then slowly we increase the force. But then also the object don't start the motion. So we can say as we increase the as we increase the external force, the static friction also increases and it opposes the motion. But here, static friction increases up to certain maximum value. And if your external applied force is greater than that maximum value of static friction, then after the object will start the motion. Clear? So here the limiting value of the static friction, that is represented as Fs maximum, and this maximum static friction directly proportional to normal reaction. It does not depends on the area of the contact surface. Clear? Remember this thing. So here we can write Fs maximum, that is mu s into n, where mu s, that is known as coefficient of static friction, which depends on the nature of the surfaces which are in contact as well as on temperature. Okay. Now, the law of static friction thus be written as Fs is less than or equal to mu s into n. Clear? And if we increase the external force, this Fs increases up to Fs maximum, and when static friction is Fs maximum, at that time it is equal to mu s into n. And when external force is greater than this Fs maximum, body start the motion, right? And now here, if body start the motion, then what happens? External applied force is F. Now the force which one is opposing the motion, means the force which is in the opposite direction of this one, that is Fs maximum. Okay, and we can say now F minus Fs maximum, that is the net force acting on the body, and if we divide this one by m, then body will start the motion with acceleration A equal to F minus Fs maximum upon m. Clear to all of you? Now next is kinetic friction. Now we discuss this thing, as we increase the external applied force, static friction also increases up to certain limiting value, and that is the Fs maximum. When our external applied force exceeds that Fs maximum, then object start motion, means object slide on the surface. And as soon as the relative motion starts, the static friction Fs maximum, that decreases. Okay, and here the frictional force that is present which opposes this relative motion, and that frictional force which opposes this relative motion, that is known as kinetic friction or sliding friction. Here kinetic friction also does not depend on the area of the surfaces which are in contact, as well as it is nearly independent of the relative velocity. Here, just like static friction, the kinetic friction also depends only on the normal reaction. So Fk proportional to n. So we can write Fk, that is mu kn, where this mu k proportionality constant, that is known as coefficient of kinetic friction. And Experimentally we observe this thing, when the body starts sliding on the surface, then the friction decreases slightly, then Fs maximum. So kinetic friction is less than Fs maximum. So here we can observe this thing, mu k, the coefficient of kinetic friction, that is less than the coefficient of static friction. Clear to all of you? Now example 4.7. Determine the maximum acceleration of the train in which a box lying on its floor will remain stationary, given that the coefficient of static friction between the box and the train's floor is 0.15. Now see here, one thing that we have to understand here, when the train is moving and motion of the train, that is accelerated one. Okay, so here we can say this thing, the train, that is the frame of reference, and the box inside it on the floor, that is the object in the frame of reference. When there is accelerated motion of the frame of reference, at that time the pseudo acceleration is imparted on the object inside it. Now, due to that pseudo acceleration imparted, the pseudo force also exert on the object, and that is in the opposite direction of the acceleration of the frame of reference. Now let's try to understand this thing with very simple example. Suppose you are standing in the bus, and bus is moving with a constant speed. Okay, so acceleration is 0. Now all of a sudden, suppose driver applies the brakes. Now velocity all of a sudden decreases. It implies that the motion of the bus is now accelerated. But when the speed is decreasing, or in other words we can say the magnitude of the velocity is decreasing, the acceleration is in the opposite direction of the motion. Clear? Bus is the frame of reference and you are the object inside the bus. Now what happens to you? When all of a sudden the brakes are applied, the acceleration of the bus is in the opposite direction of the motion and you lean forward. You lean forward because the pseudo acceleration imparted on you due to accelerated motion of the frame of reference, and due to that the pseudo force exerts on you, and that is in the opposite direction of the acceleration of the frame of reference. So here what happens, when the train is accelerated one, so on the box which is on the floor, the pseudo force exerts in the opposite direction. So actually box should move, but the friction is there, and due to friction its motion is opposed. So that box remains stationary. But as the acceleration of the train increases, the pseudo force on the box also increases. So static friction also increases. But there is the limiting value of static friction, that is Fs maximum. So corresponding to that, the train can be accelerated up to certain maximum acceleration. After that, if the acceleration increases, then the pseudo force on the box increases and box will start the sliding on the floor. Clear concept? Now mu s, that is given to you 0.15. So here we can say Fs, that is equal to Ma, because Fs, that is balancing the pseudo force that is mass into acceleration of the box. But acceleration of the box means acceleration imparted on the box, that is exactly equal to acceleration of the train. Clear? So here if we increase the acceleration, then Fs also increases, and when A is maximum, static friction that is also maximum, Fs maximum. So we can write Fs maximum, that is mu s into n. Now we have to find the maximum acceleration of the train, for which box remains stationary. So A max, that is mu s n upon m, but n that is mg, mm cancel, so A that is mu s into g. Mu s that is given to you 0.15, so 0.15 into 10, that is 1.5 meter per second square. It implies that if train accelerates with acceleration more than 1.5 meter per second square, definitely the box on the floor will start sliding in the opposite direction. Clear to all of you? Example 4.8. See figure. A mass of 4 kg rests on a horizontal plane. The plane is gradually inclined until at an angle 15 degree with the horizontal. The mass just begins to slide. What is the coefficient of static friction between the block and the surface? Now see here the figure. The block is on an inclined plane, angle of inclination that is theta. So here the weight of the block, that is vertically downward, normal reaction perpendicular to the surface. If friction is not there, then block will slide in downward direction, but due to friction it is not sliding, means friction that is in the opposite direction of the motion. So here is static friction Fs. If this angle is theta, this will be also theta. So here if we take components of mg perpendicular to the surface, then that is mg cos theta, and parallel to the surface, then that is mg sin theta. Here block is stationary. It implies that block is in equilibrium. So forces which are parallel to the surface as well as perpendicular to the surface are perfectly balanced. So we can write Fs that is equal to mg sin theta and n that is equal to mg cos theta. If we take ratio here, then mg will be cancelled, sin theta upon cos theta, that is tan theta. So Fs upon n, that is tan theta. Now as we increase the angle theta, then tan theta also increases, right? Or we can say sin theta increases. So the force parallel to the surface also increases. So definitely the frictional force also increases, right? But frictional force will increase up to certain limiting value, that is Fs maximum. So for the value of the theta, suppose that is theta maximum, for which Fs, that is Fs maximum, up to that the block remains stationary, and now we can say the block is on the verge of sliding. If theta increases slightly, then this one block start sliding. Clear? So here it is given to you. The angle theta maximum is 15 degree, for which it is stationary, and then after it will start the motion. So we can write here Fs maximum upon n, that is equal to tan theta maximum. Okay. Now Fs maximum, that is mu s into n. So n will be cancelled. So tan theta maximum, that is mu s. Clear? So theta maximum, that is given to you 15 degree. So tan 15 degree, that is 0.27. So we can say the coefficient of friction between the block and surface, that is 0.27. Clear? Now dear students, example 4.9. What is the acceleration of the block and the trolley system shown in the figure? If the coefficient of kinetic friction between the trolley and the surface is 0.04, what is the tension in the string? Take G equal to 10 meter per second square. Neglect the mass of the string. Now here the string is connected with trolley and the block. So here entire system will move with common acceleration. It implies that this particular trolley having mass equal to 20 kilogram and the block, which one is with mass equal to 3 kilogram, both will move with same acceleration. Now see here, suppose acceleration of the system, that is A, and here tension produced in the string, that is T. Okay, so here let's first prepare the equation of motion for both the objects, trolley and block. So here both have the same magnitude of acceleration that we discussed. Now for trolley, if we take acceleration in this particular direction, then we can say the tension T minus Fk. Fk, that is the kinetic friction, because friction that is in the opposite direction of the motion. So T minus Fk, this will give the net force acting on the trolley, and net force, that is mass into acceleration. So T minus Fk, that is equal to ma. Clear? Now Fk, that is mu k into n. So we can write T minus mu k into n, that is equal to ma. But here in vertical direction the equilibrium is there. So we can say n equal to mg, m that is 20 kilogram, g that is 10. So mg, that is 200 Newton. So here we can substitute n, that is equal to mg. Now substitute all the values given to you. So T minus mu k, that is 0.04, g that m, that is 20 kilogram, g that is 10, and m, that is 20. So if we solve this one, we will get the equation T minus 8 equal to 28, the equation number 1. Now let's prepare the equation of motion for this particular block. Block is moving in downward direction, acceleration is downward. So we can say mg minus t, that is the net force acting on the block. So mg minus t, that is the net force, and net force, that is mass into acceleration. Clear? Now see here. Substitute the values. M, that is 3, g that is 10, t as it is, m that is 3 kilogram, a as it is. So again here we will get the equation 30 minus t equal to 3a. Say this is equation number 2. Now if we take the summation of equation number 1 and equation number 2, then we will get t minus 8 plus 30 minus t, that is equal to 20a plus 3a. So we will get 22, that is equal to 23a. This t will be cancelled. So we can write here acceleration a, that is equal to 22 by 23 meter per second square. Now in either of the equation 1 or 2, if we substitute the value of a, then we can calculate t also. See here, we have the equation t minus 8, that is 20a. So a, that is 22 by 23. So we can write T, that is equal to 8 plus 20 into 22 by 23. If we solve this one, we will get tension in the string, that is equal to 27.1 Newton. Clear to all of you? Now next topic, that is rolling friction. In practice we observe this thing: if the body is rolling on the surface, then to continue its rolling motion, we have to apply some external force. So we can say definitely there is the force which one is opposing this rolling motion, and that particular friction, that is known as rolling friction. Actually rolling friction, that is very small compared to static friction and sliding friction. It is 2 or 3 times less in magnitude compared to other two frictions. Actually here when we observe the object which one is rolling on the surface, we feel that a point of the body is in contact with the surface. But no, actually at microscopic level, a small part of the surface of the rolling body, that is in contact with the base surface, right? So here when two surfaces are in contact, friction will be there. So the component of the contact force between these two surfaces parallel to the surface, that provide the rolling friction. Clear to all of you? Now advantages and disadvantages of friction. Now in so many cases the friction is undesirable. When the friction is there, so due to friction the motion is opposed, and due to opposition of the motion, right, the energy, or we can say the mechanical energy or the mechanical power, that is dissipated in the form of heat. So that is pure loss of energy, right? So it is undesirable there. Now to reduce the friction, what we do? So we know this thing, the rolling friction, that is the minimum one. So we use ball bearings between the surfaces, as well as we use lubricants between the surfaces, just like oil, grease, and sometimes we form cushioning between the surfaces. But on other hand, the friction that is necessary in some cases. Suppose we think about very slippery road, then on slippery road it is impossible to drive the vehicle, right? Any type of vehicle, car, two-wheeler will slip off. So friction is necessary for the vehicle between tires and roads, then only the motion of the vehicles that is possible. And friction is necessary for the braking system also. If friction is not there, then we can't apply the brakes to stop the vehicles, right? So there are advantages as well as disadvantages of the friction. Clear to all of you? Dear students, now next topic, that is circular motion. Now we know this thing: if any object having mass m is moving with velocity v on the circular path, then its acceleration, that is v square by r, and that acceleration is towards the center. So that is the centripetal acceleration, right? Now if for any object we want to sustain the circular motion, then as per Newton's second law of motion, we must provide the centripetal force, that is equal to mv square by r. So if this much force is provided to the object, then its circular motion that will be sustained, okay? And this force that should be towards the center, therefore it is known as a centripetal force. Now let's think about the motion of a car on the level curved road, right? Now suppose a car having mass m that is moving on the curved path, and that curved path, that is the level path. Here the radius of the curvature, that is r. So if it is moving with speed equal to v on this curved path, its centripetal force, that will be v square by r. It implies that to sustain its motion, the required centripetal force, that will be mv square by r. Now here, how many forces are acting? Say, one force, that is weight of the car, that is mg, which is in downward direction. Second force, that is the normal reaction, right? That is by the road on the vehicle, that is vertically upward. And the frictional force, which is parallel to the surface towards the center between car tire and road. Clear? Now see here. Since there is no vertical acceleration, or in other words we can say there is vertical equilibrium of the car, therefore n and mg are perfectly balanced. So we can write n minus mg equal to 0 or n equal to mg. Now see here, we must provide the centripetal force, and that is equal to mv square by r. So which force is towards the center? The friction between tire and road parallel to the surface towards the center will provide the required centripetal force, mv square by r. So we can say centripetal force will be provided by static friction, that is mv square by r, right? Now here, this required centripetal force, that should be less than Fs maximum, because see here, if we increase the speed v, then required centripetal force increases. No doubt, here friction also increases, but friction have certain limit. It can increase up to Fs maximum, which is equal to mu s into n, but n equal to mg. So we can say Fs maximum can be increased up to mu s into mg, where mu s, that is the coefficient of static friction between tire and road. It implies that, see here, frictional force can't be increased from this value. So our required centripetal force to sustain the motion of the vehicle on that curved level road, that should be less than or equal to Fs maximum, right? Or we can say that should be equal to less than or equal to mu s mg. Okay? Now, here, if mv square by r is less than or equal to mu s mg, then vehicle can move safely on the road. Suppose here, velocity increases, then this required force, right? Means friction maximum provide this much force. If your required force is greater than this one, who will provide it? So now in that particular case, your vehicle will slip off from the road, right? So here we can write mm cancel. If we take r on this side, then v square, that should be less than or equal to rmg. So v maximum, that should be equal to under root mu s rg. And this v maximum, that we can say that is the maximum safe speed of the vehicle on that particular given curved road. If your velocity is greater than this one, then definitely the vehicle that will slip off from the road. See here, very important thing that you can observe in this equation of the maximum safe speed for the motion of the vehicle on the curved level road. In that, mass of the vehicle is not appearing. It implies that this one is true for any type of vehicle. For the given curved level road, the maximum safe speed that is same for bicycle, scooter, motorbike, car or truck, any vehicle. Here, if move on that road with a speed greater than this V maximum, then definitely it will slip off in outward direction. Clear to all of you? Now next topic, that is motion of a vehicle on banked curved road. Now see here, we already discussed about the maximum safe speed for the level curved road, right? So if any vehicle move on that particular road with speed greater than V maximum, which is equal to under root mu S R G, definitely that vehicle will slip off. Now here on that particular road, if you want to increase the maximum safe speed, then what we have to do? We can't change the radius of the curvature. We can't change the coefficient of static friction between tire and surface of the road, right? So here in that particular equation, we can't change anything. And then also, if you want to increase the maximum safe speed, then what to do, right? So let's discuss this motion of a vehicle on banked curved road. Suppose the road is banked at angle theta towards the center. So angle is made at the center by this bend road, and that is equal to theta. Now let's derive the equation for the maximum safe speed in this particular case. Now here again think about the forces acting. Weight of the car mg vertically downward. Normal reaction perpendicular to the surface. If this angle is theta, here this will be also theta. So you will get components of this normal reaction, that is n cos theta vertically upward, n sin theta in horizontal direction, and that is towards the center. Then the friction between tire and road parallel to the surface, right? And that is towards the center, which will provide the required centripetal. So here also, if we take the components of this one, because here the road is inclined at an angle theta. So if this angle is theta, this will be also theta. So in this particular case, we will have the components of frictional force F cos theta towards the center and F sin theta, that is vertically downward, right? So here in this figure, all the forces are represented from the common point. So we can say that is free body diagram. Now here in vertical direction, there is no acceleration. So in other words, we can say there is vertical equilibrium. It implies that we can write n cos theta, that is equal to f sin theta plus mg. Okay, n cos theta, that is f sin theta plus mg. And the forces which are towards the center. Here two forces are towards the center, n sin theta, f cos theta. So these two will provide the required centripetal force. So here in this equation, if we make mg as a subject of equation, we can write n cos theta minus f sin theta. Now the required centripetal force mv square by r will be provided by these two forces which are towards the center, f cos theta and n sin theta. Therefore mv square by r, that is n sin theta plus f cos theta. Now take ratio of equation 3 and equation 2. M will be cancelled, so we square upon Rg, that is n sin theta plus f cos theta upon n cos theta minus f sin theta. Now here if V increases, then definitely F also increases to provide the required centripetal force. But F can be increased up to certain limit. So for the maximum shape speed V max, here we can take F that is equal to Fs maximum. So here we can write one more step, and that is V square maximum upon Rg, that is equal to n sin theta plus Fs maximum cos theta upon n cos theta minus Fs maximum sin theta. Now this Fs maximum that we can replace by mu s into n. So we can write this is equal to n sin theta plus mu s into n cos theta upon n cos theta minus mu s into n sin theta. Now if we take n common, then that will be cancelled. Clear? Now if we take this Rg on right hand side, then we can write V maximum square, that is Rg into sin theta plus mu s cos theta, numerator, and denominator cos theta minus mu s sin theta. Now on right hand side, divide numerator and denominator both by cos theta. So here sin theta upon cos theta, that is tan theta, cos theta cancelled, so plus mu s, cos theta upon cos theta 1 minus mu s sin theta upon cos theta, that is tan theta. So mu maximum, that is under root Rg into mu s plus tan theta upon 1 minus mu s tan theta. Now remember, on level curved road, the maximum shape speed was under root Rg into mu s. But here see, something is added to mu s plus tan theta, and then after that numerator is divided by the term which one is less than 1. So definitely this bracketed term that will be greater than mu s. So we can understand this thing. Now this maximum shape speed on the banked curved road, that is greater than the maximum shape speed on the level curved road. So to increase the maximum shape speed on the given level curved road, we have to give inclination to the road like this by some angle theta. Clear to all of you? Let us consider following two special cases in this discussion, right? Suppose in the equation of V maximum previously we derived, if we take mu s that is equal to 0, it implies that the friction does not act, or we can say the friction is minimized one, right? So if we take mu s equal to 0, our equation turns to V that is equal to under root Rg tan theta. This is denoted as VO. This particular speed, that is known as optimum speed. If the vehicle is moved on that particular banked curved road with this speed, then the friction that will be least one, and the contribution of friction in the centripetal that will be almost 0, right? So in that particular case, the wear and tear of the tires of vehicle, that will be minimum 1. So if vehicle is moved on that particular banked curved road with this speed, which is known as optimum speed, then wear and tear of the tires can be minimized. Now let's think about another case. If speed is less than optimum speed, right? Then what happens? The frictional force will act in opposite direction, means towards higher side. So vehicle will slip off inside, right? So on the banked road, if you want to park the vehicle, right? So in that particular case, your tan theta that should be less than or equal to mu s. If this condition is not satisfied, and if you park the vehicle on the banked road, then it will slip off towards the center. Clear to all of you? Now example 4.10. A cyclist speeding at 18 km per hour on a level road takes a sharp circular turn of radius 3 meter without reducing the speed. The coefficient of static friction between the tires and the road is 0.1. Will the cyclist slip while taking the turn? So here, first of all, we have to think about the maximum safe speed on this particular given level road. Say here, V that is 18 km per hour. So 18 into 5 by 18, so that is 5 meter per second. Cyclist is moving with speed 5 meter per second. Radius of curvature that is 3 meter and mu s is 0.1. Now maximum safe speed on the horizontal curved road, that is V maximum equal to under root mu s r g. Substitute the values here. Mu s that is 0.1, r that is 3, g 9.8. Here you can take 10 also for easy calculations, raised to 1 by 2. So your answer that will be 1.71 meter per second. Now see here, cyclist is moving with the speed 5 meter per second. So speed of the cyclist that is very much greater than the maximum safe speed, right? And therefore in this particular situation, cyclist will slip off from the road because its speed that should be less than or equal to V maximum, but here the speed of the cyclist that is greater than V maximum. Clear? Now example 4.11. A circular race track of radius 300 meter is bent at an angle of 15 degree. If the coefficient of friction between the wheels of the race car and the road is 0.2. What is the A. Optimum speed of the race car to avoid wear and tear on its tires, and maximum permissible speed to avoid slipping? Okay. Now see here. We derived the equation for optimum speed as well as V maximum for the given curved banked road. Now here the banking that is given to you 15 degree, radius of the track that is 300 meter and coefficient of friction that is 0.2. So we have the equation for the optimum speed VO that is under root RG tan theta. Substitute here the values. So VO that is 300, G that is 9.8, or you can take 10 also, into 10 15 degree raised to 1 by 2. Now if we solve this one, then optimum speed turns to 28.1 meter per second. Now let's calculate the maximum permissible speed to avoid slipping. Now maximum permissible speed V maximum that is under root Rg into mu s plus tan theta upon 1 minus mu s tan theta. Again substitute all the values here. R 300, G 9.8, mu s 0.2, tan theta that is tan 15 degree, 1 mu s 0.2, tan theta that is tan 15 degree whole raised to 1 by 2. Now, if we solve this one step by step, then our answer that will be V maximum equal to 38.1 meter per second. Clear to all of you? Now, dear students, example 4.12. See figure. A wooden block of mass 2 kg rests on a soft horizontal floor. When an iron cylinder of mass 25 kg is placed on the top of a block, the floor yields steadily and the block and the cylinder together go down with an acceleration of 0.1 meter per second square. What is the action of the block on the floor? A. Before and B. After the floor yields. Take G equal to 10 meter per second square. Identify the action-reaction pairs in the problem. Now see, first think about this first case. Now in first case, the block is at rest on the floor. So weight of the block in downward direction, that is mg, and normal reaction r, that is vertically upward. And here the block that is in equilibrium means these forces are perfectly balanced. So we can write R, that is equal to mg, that is 2 into 10, that is 20 Newton. Now in second case what we do? Here a cylinder of mass 25 kg is placed on the block. So the floor yields. So entire system move in downward direction with acceleration A. So here the situation is like this. Mass of the cylinder capital M, of the block small m. This system move downward with acceleration A, right? So here weight of this system in downward direction, that is m plus m into g, and the normal reaction by the floor on the system in upward direction, that is r dash. And resultantly the system moves downward with acceleration A. So we can say, as per Newton's second law of motion, the net force, that is m plus m into g minus r dash, that is equal to mass into acceleration. So here make r dash as a subject of equation, take m plus m into A on left hand side. So m plus m into g minus m plus m into A, that is equal to r dash. Here take m plus m common. So we can write m plus m into g minus A, that is r dash. Now substitute the value, small m, that is 2, capital M, that is 25, g, that is 10, and acceleration that is given to you 0.1. So if we substitute all this value and then after if we solve it, the answer will be 267.3 Newton. Now see here, we have to identify, here there is a mistake, identify the action reaction pair in the problem. So in first case, the force on the floor by block, if we say that is the action, then force on block by floor, that is reaction. Or if we say force on block by floor, that is action, then force on floor by block, that is reaction. So in this way we can say any one force as an action, then the another that will be reaction. In the same manner we can take force on the system by the floor, that is action, then the force on the floor by system, that is reaction. Or we can say force on the floor by the system, that is action, then force on the system by the floor, that is reaction. So in this way we can identify the action reaction pairs. Clear to all of you?